Hi everyone, so I'm going to be doing another AP Physics C free response. This one is from 1989, Electricity 3, and like always I just redrew the figure here and I'll read the question out loud. A battery with an EMF of 20 volts is connected in series with a resistor of 300,000 ohms and an air-filled parallel plate capacitor of capacitance 6 microfarads. So that is the capacitor right here. That's the resistor, and that's the battery with 20 volts. Part A. Determine the energy stored in the capacitor when it's fully charged. Okay, so for part A, the capacitor is fully charged, and to find the energy, all we have to do is use U, the energy, equals 1/2 CV squared. And then we just plug in our values, so we get 1/2 times C, which is 6 microfarads, so 6 times 10 to the negative 6 farads, times the voltage, which is 20 volts, 20 volts squared. Doing that out will give us 1.2 times 10 to the negative 3 joules. Okay, part B says, the spacing between the capacitor plates is suddenly increased in a time short compared to the time constant of the circuit to 4 times its original value. Determine the work that must be done in increasing the spacing in this fashion. Okay, so part B. Now we want to find out the change that happens in work. So because the spacing is different, the capacitance is going to vary. But because this circuit is connected in series, the Q is going to be the same. So Q is constant, that means VC in both instances has to be constant. This is what it was, and this is what the voltage and the capacitance will be after the spacing. So we know that capacitance equals the permittivity constant times the area over the distance. But C prime would thus equal the permittivity constant times the area, because that doesn't change, times 4 times the distance, since that's what the distance is increased by. But that's basically just C over 4, because this right here is C. So now that we know that C prime equals C over 4, we can find out that V prime, which equals VC over C prime, will equal VC over C over 4, and that's just basically going to be 4 times the voltage. So now using this information, we can figure out what the change in work is going to be. So work is just the change in your energy, or potential energy in our case, equal 1/2 CV squared final minus 1/2 CV squared initial. Okay, so we can just plug in the values we know. So we'll have 1/2 times C final, or C prime, and V final V prime are what we just found out above. So our C is going to be C over 4. Our V is 4V squared minus 1/2 CV squared. Now we can simplify this more, so we'll have 1/2 times C over 4 times 16 volts minus 1/2 CV squared. And this is simplified, will give us 1/2 times 4, oh, there's a square right here, 4 CV squared minus 1/2 CV squared. And that's just basically 1/2 times 3 CV squared, or 3U. And now U is what we just found out above, right there. So we can just plug in and we'll get our answer. We'll have 3U, which equals 3 times 1.2 times 10 to the negative 3 joules, which is 3.6 times 10 to the negative 3 joules. And that's the work that must be done when the spacing is increased. Okay, part C says, determine the current in the resistor immediately after the spacing is increased. Okay, so part C. To find current, we can use V equals IR, but to solve for current, we'll isolate it, so we'll have I equals V over R. Now, our V, after the spacing increases, is going to face a change. So we'll have V final minus V initial over R. And our V final, what we said before, is going to be 4 times V. So we'll have 4V minus V over R, which is just 3V over R. And our V, as said in the diagram, is 20. So this is basically going to be 3 times 20 volts over 300,000 ohms. And that, when it's all calculated, is 2 times 10 to the negative 4 amps. Okay? Part D. After a long time, the circuit reaches a new static state. D. Determine the total charge that has passed through the battery. Okay, so we'll do part D over here. So now they want to know the total charge. So to find the total charge, we'll use delta Q equals Q initial minus Q final. So for Q initial, we have Q equals VC. And that just is plug and chug what we had the original values. And that's just our V is 20 volts. And the capacitance is 6 microfarads, so that just gives us 120 microcoulombs. Now for Q final, we have a difference in the capacitance. The voltage in the battery will still be the same. So we just write V times C prime. And the voltage is still the same, and the C prime is now C over 4. So that. And this is basically just going to be 20 volts times 6 microfarads over 4. And when this is done, we'll get the answer of 30 microcoulombs. So like I said above, we have to subtract the initial from the final, so we have 120 microcoulombs minus 30 microcoulombs, what we found out from these two parts, to give us 90 microcoulombs. And that is the total charge that is passed through the battery. Microcoulombs, sorry. And now we have the last part, E. This reads, determine the energy that has been added to the battery. Okay, so now to find the energy, there's a formula. So the change in energy is going to be the change in the charge times the voltage of the battery. So the change in Q we just figured out, which was 90 microcoulombs. So we have 90 microcoulombs, and the voltage of the battery is 20 volts. And that just simply gives us 1800 microjoules. And that's the energy that's been added to the battery. So that's basically it. Yeah, that's it for now. Bye!